Hello and welcome to another wonderful example of Mr. Wernau does your homework. So we're going to take a look at some double integrals. We'll take a look at some easy ones and move on some hard ones. So for this example right here, we want to find and integrate the double integral for x plus y dy dx. Now recall, we are going to integrate the inside function first. So that means we're going to integrate with respect to y. And if we integrate this with respect to y here, we're going to get xy plus y squared over 2. And we're going to evaluate that from 0 to 2. Remember, we're only dealing with the y variables, not the x's right now. And if we use the fundamental theorem of calculus, if we plug this in for the y's, we would get 2x plus 2. Because if I get this becomes 2x, that becomes 4 over 2, which is just 2. And then minus, plug in the 0, and that's nice. We just get 0. So we'll put 2x plus 2 for our region, for our first integral. Now we're going to deal with the outer limits. Great show, by the way. Dealing with the outer limits, now we're going to integrate this with respect to x. So my new integral will be this 2x plus 2 dx from 0 to 1. And integrating here, don't forget this just becomes 2x squared over 2, or x squared plus 2x, and we're going to evaluate that from 0 to 1. And plugging in the 1, we're going to get 1 plus 2 minus just 0, and we're left with 3 right there. Very easy to do. All right, let's take a look at another example. Let's get a little bit triggerlicious with it. So this one we got the function y cosine of x. So don't forget, even though it looks kind of confusing, some people think, oh no, we got an integration by parts. But just remember, because we are integrating with y first, we're going to hold x as a constant for now. We'll deal with that later. So when we integrate this with respect to y, we're going to get y squared over 2 times the cosine of x. We just leave it as a constant. We evaluate that from 0 to 1. Remember, these go in for my y's, not my x's. So when I plug in 1, that's going to give us 1/2 cosine of x minus, plug in the 0, that just becomes 0. We're left with 1/2 cosine of x. And now we're left with this function in terms of x, and that's my last integral. Since we did the inside, now we're going to do the outside integral. So we get this 0 to pi over 2, 1/2 cosine of x dx, and you should remember that the antiderivative of cosine is sine. So we're going to get 1/2 sine of x, and we evaluate that from 0 to pi over 2, which becomes 1/2 sine pi over 2 minus 1/2 sine of 0. Yes, we do expect you to know this. This just becomes 1, and that's just 0. So we're left with 1/2 right there. So easy. Even a senior in May can do this stuff. All right, so let's take a look at another example. But in the next example, we're going to take a look at what happens if one thing in our domains, in our limits, is a variable. And that's number 19 right here. So for example number 19, notice this time when we integrate, whoops, that should be dy dx, forgot that. When we integrate this one, we're going to integrate with respect to y first. Now be careful, notice one, there's nothing a y in here, so we're kind of cool with that. That shouldn't be too bad for us. But one thing I do want you to notice is that the limit that has the variable is the inside one. And that, from another video, we talked about that before. That's very important. You don't want to have the variable in the outer limit right here, only on the inner one. And the inner one should match up with your outer variable. It's differentiable. So this x has to match with that dx, in other words. So when we integrate this with respect to y, that's not too hard to do. Since there is no y, we just get 1 minus x squared y from 0 to x. And of course, that just becomes the square root of 1 minus x squared times x minus, of course, 0. And I'm going to rewrite this as x times the square root of 1 minus x squared. Ooh, that looks ugly. So now that's what we're going to integrate. From 0 to 1, x times the square root of 1 minus x squared dx. Not too bad. I recognize right away that x squared's derivative is x. So we're going to use u substitution. U is 1 minus x squared. Du is negative 2x dx. Dx is du over negative 2x. And those x's will cancel, and that's what we like. And what we're left with, we can do this real quickly because remember this is just u to the 1/2. We got this negative 1 over 2 that we don't want to forget about. And this is the antiderivative of u to the 1/2, which is 2/3 u, which we already know is 1 minus x squared to the 3/2. And we'd evaluate that from 0 to 1. Right there. So of course the 2's cancel, and we're left with negative 1/3. And if I put in the 1 here, 1 minus 1 is just 0. Minus, plug in 0, and we get 1 to the 3/2, which is just 1. And what are we left with? A negative times a negative, positive 1/3 right there. All right. Go on to the next video, and we'll take a look at a few more examples, one with we have to deal with limits. I'll see you then.